I want to say a little bit more about strings in C because they're, useful and quite a bit different than strings in C++ and Python. They're kind of bare bones sorts of things. Um, all right, so let me, don't want to spoil the surprise here. I've actually been practicing a little bit this time, so maybe this video will be a little bit better. So let's say that you want to declare a string. And C, that's just an array of characters. And one way to do that is to say, um, so you could make the array some definite number of entries, like let's say 100 characters, which you can also think of as 100 bytes. And you could type in something like this and print it out again. And you can see the output is just the string that you just typed. Maybe it might be a little bit more informative to print out some data about the string, like maybe how long it is. Okay. And what's wrong? Oh God, I hate this. It's the size t thing. strlen returns a size t, which is an unsigned long or something like that. So it says that the length of the string is 22, and I guess that's probably right, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And okay, so there are 22 characters. Even though the buffer is 100 entries long, the reason it knows that it's 22, how could the system know that? It's because this thing is secretly null terminated. So a string is a null terminated array of characters. So this function is kind of silly. It just looks through and it's looking for the entry here that's 0. And so this thing automatically puts 0 as the last entry. And in fact, we could probably, just look and see. Let's try to do that. So what is, let's print it out as a hexadecimal. What is blah 22? So it's 0. So there it is. It's the null terminating character. Okay, so let me show you a couple other things. You can, for one thing, leave the 100 out if you want to. It's probably better to put the 100 there because then you know for sure how much memory has been allocated to that array. But the system will allocate enough memory for you automatically. The compiler is just smart enough to do that on its own. Another thing is, let me put in something here. What if we want to make this string more modest, and let's change the first letter from uppercase I to lowercase I, and then print out the string again. Okay. And so you can see that the lowercase I is there now. So that is not too interesting, but let me comment this stuff out for a second. So another way to declare a string is like this. So now instead of using the array notation, I'm using the pointer notation. And there's a close relationship in C between pointers and arrays, which I don't think we've talked much about, but an array sort of is a pointer, and there's going to have to be a whole discussion of that. But this will work also, and let me make sure it's saved here. Okay, so has the same output as before, but there is a difference. When you do it this way, the string is fixed. You can't change it. If you try to change it, you get a segmentation fault. So remember, a segmentation fault is an error that comes up when you try to access some memory that you don't really own. And so how is that happening in this case? I guess the place where this string is stored must be a region of memory that we're not allowed to modify. and when you do try to modify it, the system blows up. All right, so those are the basics. By the way, for the string length function, you need to include that header. There are also some useful things that I'm going to be talking about that are in that header, but those are the basics. And so now let's get a little bit crazier. So I want to at least do this though. For I equals 0, I is less than strlen blah I plus plus. What do I want to look at? I want to look at the memory addresses of the array entries. So those are pointers, and I'll say that I want 10 spaces to represent the pointer, and I also want to look at the character as a hexadecimal, and let's use 5 spaces for that. And I want to look at the character just as an ASCII character. So I'll allocate 5 spaces for that. So what I want here is the address. Here's the address operator of the ith entry of the blah array. And if that's confusing, hopefully what I'm trying to do now is just sort of explain what the index of an array really does. And now let's just put blah I and blah I. And we could erase these things that make this thing angry. Let's not change the string. Sorry, my nose is a little stuffed up. All right, and here's the output, and you can see that these are the memory addresses. So I want you to notice that like all arrays in C, the memory is contiguous. That means one address comes right after another. Do you see how this is just counting up in hexadecimal here for the addresses? So it starts at this location and then it goes contiguously up to this location. And if we include that last one, you can actually see the terminating 0 too. And there it is, right? So that doesn't print as an ASCII character, but that 0 is there. And if that 0 is not there, then weird things happen. Let's say that I want to be perverse, and I change, I believe it's still 22, right? If I change that terminating entry to 1, and I have to put in a semicolon, one thing that's going to go wrong here is that the string length function is not going to work. And yeah, so now it seems like it just happened that there was it just keeps going, right, until it gets to the 0, and then it thinks that that's the terminating. It thinks that that's the null terminator, and 1 is a non-printing ASCII character, so you get this weird matrix. So yeah, let's not pervert the thing. And right, it's kind of cool. So this sort of relationship between arrays and pointers that I'll talk about more later is so the 0th, in a certain way, blah is a pointer. So notice here I've used the array notation, and I can even write it as like that. And let's say that I have a pointer to a character b, and b is equal to blah. Now this makes sense, and now if I print out the memory address of b, it will be the same as this, which is the memory address at which blah starts. And here it is, right? So my input is getting a little dirty, but do you see that this ends in 330? This ends in 330. They're the same, but they're not exactly the same. One difference between them is, like we've done in previous videos, probably my worst video ever, you can do things like this. I'm gonna sneeze. Okay, I'm not gonna sneeze. So you can increment b, and then you print it out again, and it just goes up to the next number. Maybe I should put in a a space here so things get less confusing with the output. I'll put in a couple new lines there. Alright, so here is B, and here is B incremented to point to the next memory address, and you can use that you can use B to print out that character if you want. It's so what should that be? That should actually be a space. That's not going to be a very interesting character, but it will still print it out, and you can see that the space is right there. And let's make it a little bit more interesting by going up even further. And so now it'll be a printing ASCII character, and it'll be T. This is the T which starts the word think. I'm going to pause the video and blow my nose. That's disgusting. I should just have done it and not told you. Ah, so satisfying. And in case the thing gets frozen, let me spin this around a little bit. All right. And so here what we've been doing, actually 0 time has passed for you, even though I've had a massive allergy attack. It seems like blah is the same as B. Let me show you another way in which they're the same. So dereferencing is also the same as getting the 0th index. So you can use the index notation for pointers also. So this will still print out T just like before. And you can even go on and what do you think this will be, right? Change it to 1, it should be H. And so this index or subscript notation works fine with pointers. But there is a difference between things that are declared to be arrays and things that are declared to be pointers. And the difference is that this is like a constant pointer. You can't change its value. So if down here you try to do blah plus plus, you shouldn't do that, and it gives me a compile time syntax error. It says you can't increment an array. But if you want to do that, then you can just set pointer equal to it and then manipulate the pointer. Okay, so let me erase all this stuff. And now I want to tell you about some useful functions that live inside here. So let me just make a list of them, and I don't want to make it too incredibly boring, so maybe I'll skip some, but some of the interesting functions in there are strlen, which we've already seen, str compare. So this is just alphabetical ordering. It tells you which string comes first in alphabetical order. Str copy, which if you are in FCM 708 or 709, you know that can cause big security problems. So I think I'll talk about that one actually. Let's do another string buffer here, and also make it 100 characters. And let's say that I do str copy. Oh wow, so Genie really shows you a bunch of them. And str copy, and here it gives you the clue. The destination string comes first and the source comes second. So let's say I want to copy some of blah into buff2, and then let's have a look at the result. Oh, so it should just print out I think therefore I am, right? And it does. So string copy copies this string into here. But you know it can be dangerous because string copy doesn't check to see how many bytes are actually allocated to buff2. We've played around with this before. It's a security hazard. We know that this string is 22 characters long. Actually, it's 23 if you include the null character. So let's say that I only allocate 10 bytes to buff2. It'll probably still work. See, it works. Doesn't even complain. But what you're doing now is you're overwriting other things in the stack, and bad things can happen. Buffer overflow attacks can happen. All right, but something that's a little bit more secure is str N copy, and then you can bound the number of characters that you actually want to copy. Let's see if this works. Let's put it back to 100. So this says copy 22 bytes from blah into buff2, um, and it works fine. But what if I say copy 15 bytes? Then it should not copy the entire string, and I'm not even sure buff2 will be null terminated. So it may just appear to be null terminated because this thing defaults, it just happens to be initialized with all zeros. And by the way, a quick way to assure that is like this. So now buff2 is 0, 0, 0, 0, 100 times because of this little syntax trick. What if I make it equal to 1? Okay, so it does put the null terminator on there, which is nice. All right, so that's string copy. By the way, another way to, there's some other seemingly non-string related functions that are inside string.h, and one of them is Mem Copy, which is an interesting and very dangerous function. And there's also one called b0. So, frequently you want to initialize an array to all be 0. And so one way to do that is just I equals int I equals 0, and then you can do a for loop. Let's say 100 I plus plus, and then you put buff2 I equals 0. So that'll set every entry in buff2 to be 0. You might think, why are you doing that, Hunter? Isn't it 0 anyway? No, it's not. This is just random memory, and it could have all kinds of junk in it. In fact, let's take a look and see what's in there. Probably frequently it is all zeros, especially since I've been kind of putting a lot of zeros into the memory that might still be there. But let's have a look and see. Let's print it out as hex, and let's just look through buff2 and see what's there by default. By the way, the for loop, sometimes I write the braces and sometimes I haven't. Maybe the rule is with braces, all this stuff is inside the for loop. But if you omit the braces, then only the immediately following line is inside the for loop. So this is a little bit misleading because the indentation makes it look like this line is also being iterated 100 times. But that's an illusion because C doesn't give a damn about the tab. It doesn't care about the white space. So be careful about that. It's an easy way to make a mistake. So let's see what's in there. So, oh, I did something stupid. Okay. Yeah, so you can see that there is some random garbage in there. There's a lot of zeros, but there's also just a lot of trash. And but if you set it all equal to 0, then it's all going to be equal to 0. And so that maybe you're not very impressed by all this, but this is a very useful thing to be able to do, is to make an array all zeros or initialize it in some other way. And so another way to do the same thing is with this little initialization trick. You can also make it all ones if you want. So that didn't work. That's surprising. Oh, it just made the very first one 1. Ah, interesting. That is something I did not know. Another way let's just do it again and see if the trash is back. Okay, the trash is back. The trash is back. Another useful function that's inside string.h is this function called b0. And one reason to talk about it is just because it has such an awesome name. And so notice that it takes void stars here, and so this is the second argument is going to be a number of bytes. And what this first argument is just a pointer to something. So this is as close as you can get to object-oriented stuff in C. And we'll talk more about void star later, but void star is a pointer to a memory location, and using void instead of char or something means that it might be a char, it might be an int, you don't care. You're just treating it as sort of like a raw memory address. So let's make buff2 be 0. Let's see if this works. Yeah, it doesn't work. So I want to make all 100 bytes 0. And now they are all 0. Okay, so more generally, you can use Mem Copy. So Mem Copy is another one of those dangerous functions, and let me show you why. So first you type the destination buffer, which is going to be buff2 for us, and now you type what it is. Oh, you can type a. Oh, you know what I'm thinking of? Let's talk about Mem Copy later, but what I really had in mind was Mem Set. And so first comes the destination buffer, and then you put the character that you want to put in all of those places. So let's put in OX41. I think that's capital A, and for 100 bytes. So now it should be all. Oh, it's just pointing out. That's because it's printing as hex. If I print it as a character, it's A. So this is dangerous because it doesn't really check to make sure that the thing is only 100 characters long. If I put in 110, it will cheerfully go along and make some more A's for me. And if I get too greedy, though, it'll probably give me a segmentation fault. Oh, it still worked. Yeah, so you can see. Finally, I got a segmentation fault. It's kind of unpredictable when it's going to happen, which is bad. You'd like it to fail every time when you do something like this. All right, so that is mem set. Now let's talk about mem copy. So you can see by the description here that there's like a destination. So let's use buff2 as the destination, and we'll use blah as the source. And it's a lot like string copy. Let's copy 22, actually 23. So what this says is take 23 bytes in blah and copy them into the first 23 bytes of buff2. And you might say, what's the difference between that and string copy? And, not much, except that, it might not put in the terminating null character. Let's see, puts buff2. So I've copied blah as a string into buff2 using the mem copy function. So we get it printed out nice and neat there. What if I do mem set buff2, set them all equal to 1, and then do mem copy? So it must, right, so now I'm copying the terminating null character, but what if I omit the terminating null character? Is it going to do something weird? Yeah, okay. All right, so that's not surprising, right? It keeps printing here until it gets to a 0 because it's looking for the terminating null character. So memcopy is dangerous for the same reason that memset is dangerous, which is that there's no check on this number 22. You could change it to 220 and it might still work. In fact, it does still work. And then if you get too greedy, you'll get a segmentation fault because you'll eventually change something that's protected. Okay, so is there anything else to say? Maybe we should just look through some of these. str, I guess we could talk about str comp and string cat, so that's useful. What do you think that does? That concatenates two strings. So let's get rid of all this crap here. And let's say this is cog cogito ergo sum, and let's concatenate those two things. So str cat can be useful, also dangerous, and let's copy it all into buff2 and from blah, and what is the result? It says cogito ergo sum, I think therefore I am, and if you want it to look nicer you could put a space there. Right. And there's also str ncat, and that allows you to put a bound on the number of characters that you concatenate, so that there's n versions of everything, so the n versions give you control over the number of bytes that are actually manipulated to stop these kinds of overflow attack type things. You can also, okay, so maybe you guys want to take a break. Why don't you go get yourself a lemonade and pause the video? Because now I'm going to start playing around, because strings are a great way to introduce pointer hopping. Let me write my own string copy, and what should it return? Let's say it returns nothing, and I'll call it my str copy. And I'll take two strings. So how do you take a string as an input? So you could do it as a char star. And maybe it would be more informative to call these the destination and the source. Okay, so what this is going to do is just like the other string copy function, it's going to copy src, presumably null terminated string, into dest, and it's not going to do any kind of bounds checking or anything, just like the regular old bad string copy doesn't. And here I'll call it my str copy, and then I'll print out buff2 down here. So right now it's not going to do anything. It's just going to be regular old buff2, and that's because nothing is happening here yet. So let's make some things happen. So I'm going to, you could do it using array notation or using buffer notation. So maybe the most straightforward thing is to do it using array notation, or index notation or subscript notation. And so how could you do that? You just say int I equals 0, and for I equals 0, I is less than strlen src I plus plus dest I is equal to source I, and that's it. So it copied the source string into the destination string, which is what it was supposed to do. Isn't it kind of weird that something that happened in this function can modify what happens to the variables down here? The reason that that's possible is because these are pointers, and so you're changing what's happening. Here you get the memory address, so once you get the memory address, you can change what values are at those addresses, and so that affects things back here too. So now let's do it using pointer hopping. And so these are not constant characters. We're free to change those. So let's do, this could be kind of confusing. What about while star source? And so just like the for loop, if there are no brackets, it's assumed that only the immediately following line is included in the iteration. So I think you only need one line. What can you do? You can do star dest. No, I'm going to need more than that. Is equal to star source. So what does that do? That dereferences both of them, and it makes this one equal to that one. Now you need to increment them. Dest plus plus, source plus plus, and C doesn't care that you don't type a return character there, and that also copies the string. See, that worked fine too. You could do this in a way that is more slick, in which you only need one line, and that's using this plus plus thing here, and you could do plus plus here. So the reason that still works is because this plus plus operator, it has the side effect of incrementing the variable, but then it also has a return value, and what it returns is the memory address before it was incremented. Then you dereference that, and it has the same effect as what was there before. You think, this is just brain busting. Why would you do these stupid things? But people use C this way. So, um, and it's good, right? It's having fun. Actually, I know from experience you've probably stopped watching by now, or else you're slapping yourself in the face trying to stay awake, or stabbing your hand with your pen, or trying to find out my home address so you can come put an end to these videos once and for all. I think you can. Oh, so we haven't said anything about why this works. What is that doing? So in C, 0 is false and non-zero is true. So what this is doing is it's looking for the terminating 0 character. So it's the terminating 0. It's not a 0 character, it's just 0. It's looking for 0, and when it gets to 0, that's when the while loop terminates. And because this thing is null terminated, that's what makes the whole thing work. In fact, if you want to get really psycho, I think you could even do it just like this. Let's get rid of that. So this is while nothing happens. Okay, and so I got a warning. Wait, did I get a... I know that I should get a warning, but I don't care. Yeah, so Clang is being... see, only one warning was generated, and it does still work. Clang is trying to be like my mom, and common error is with a conditional. You mean to... This is an assignment, and it's thinking what you really mean is comparison, but I really actually mean assignment. And the reason this works is because after it does the assignment, it returns the value assigned. The very last value assigned will be 0 because it's null terminated, and that'll make the while loop stop. And if there's some way to suppress warnings, actually this is not a very good way to write code, but people do write code this way. And so it's good to be ready. Look at that. That's the coolest function I've ever seen. And that's pretty much all I had to say, so I will actually stop now.